everyone. For my Unit 7 discussion on oscillations and periodic motion, I'm analyzing an electrocardiogram examination, aka EKG rhythms. I'm currently an EKG technician, so I'm super excited about this topic. An EKG maps the repeating electrical voltage changes in the heart over time and for a lifetime. The rhythm itself can change, but that's another topic, another discussion. We can define this system using 4 core physics concepts: equilibrium position, the flat isoelectric baseline where net electrical current is 0, amplitude, the maximum electrical displacement from baseline to the peak of the tall R wave, the period, the R to R interval, which is the time elapsed between 2 consecutive heartbeats, and frequency, the restoring force, is your heart rate, calculating how many cycles occur per second. So, side note, with EKG, with your rhythm, we have what's the P wave, the first wave, the QRS system in the middle, and then followed by the T wave. So the R to R is in the QRS system. Okay, that's another discussion to elaborate. Number 2, the restoring force and periodicity. This motion is strictly periodic because of how its biological restoring force operates. When the heart's pacemaker fires, it forces a massive influx of sodium ions into cardiac cells. This drives the electrical voltage sharply away from the equilibrium, creating the R wave spike. Immediately, active cellular ion pumps engage. They act as a restoring force by pumping potassium and sodium ions back across the cell membranes. This restores the resting negative voltage, pulling the signal straight back down to our baseline, the line of equilibrium. Number 3, why it oscillates and repeats. The system endlessly repeats over time due to intrinsic properties of the heart's sinoatrial node. These pacemaker cells have leaky membranes that slowly automatically drift back towards a firing threshold right after resetting. Ultimately, the system oscillates because the heart muscle must continuously transition between contraction and relaxation to pump blood. The specific frequency of this periodic motion is tightly regulated by autonomic nervous system signals and hormones like adrenaline, which dictate how fast these cells cycle through electrical displacement and restoration. Thanks for watching.